Thank you, everybody, for coming. Thank you for the introduction. As said, I'm Cody Bunton from NYU. I used to be at the University of Maryland in College Park, and I actually still live in Silver Spring half the week because my wife lives there and works in Bethesda. So I'm here a couple times a week. So today I'll be talking about consistencies in response to disaster on Twitter. But in conversation with Andrew a second ago, it seems like a lot of the stuff that I've been doing is pretty similar to the stuff that you've been doing. So before I talk about this, here's just like a smattering of some other stuff that I've done. I have a paper at Chi this year about disability community and online protest and how they use social media, harassment, sentiment, and offline unrest. So studying illicit drug use using social media and geographic data. And then today is consistencies in online response to crises. So to get into the talk, in the lead up to, during, and in the aftermath of crises, people use social media a lot and for a bunch of different kinds of things. From sharing information about their stories or personal experiences in Ferguson, Missouri during high-impact events like the Ferguson protests, to asking for help or sharing critical information about damage and location during terrorist attacks. But people also use social media during these kinds of events for sharing sentiment or sharing their emotional state. So we know that during the Brussels, during the so common, in fact, that in the United States. Now, there's been some really excellent work from Alexandra Altanu and her colleagues, different kinds of crises, and we see that sympathy and emotional support is actually the second most common kind of content that's in there. But there are many other kinds of content that are in there, but what I'm looking at isn't just the kinds of content, but the actual language that people use. Is there consistency in the words that people use to describe their events or their experiences after these kinds of events? Now, this consistency has actually been touched on before. NPR's Sam Sanders was talking about the Dallas sniper attack, and he referred to this as disaster scripts. That people's response to these kinds of events feels like a script, like everyone knows what they need to say. So the people of insert some place are so resilient, they will recover. Our thoughts and prayers go out to the victims and those affected by insert some disaster. So, given this kind of thing, what we're trying to figure out, or what is really the point of this talk, given this context, if you don't remember anything else about my standing up here and talking to you today, you can remember this. Public social media response shows consistencies across disasters. And these kinds of responses express several kinds of information needs. And while we can automatically detect these content that fulfills these needs, identifying the most critical content during these times is still difficult. So how will we talk about this? I'll look at three research questions here. How prevalent are disaster scripts on Twitter? So thoughts and prayers is the one that you always think about, but what are the other, are there other disaster scripts? How is the thoughts and prayers script really that prevalent? What can we learn about the disasters from these scripts? And then how can we identify the most critical information during these kinds of events? So looking at the first one, how prevalent are disaster scripts on Twitter? This question is essentially a detection question. We want to be able to identify these kinds of words, like resilient, thoughts, prayers, victims, affected, the things that people always say in response to these kinds of events. Based on some previous work looking at how social media responds to events, one of the things we've learned is that when an event happens, like a terrorist attack or some sort of natural disaster, in general, social media responds with a huge uptick in conversation about that event. It doesn't really drive new people to Twitter as a platform, at least, but the distribution of topics really spikes around this one event. It stays high for that day, and then it drops off pretty rapidly. In fact, in general, within 7 days of the event, or 7 days after the event, the amount of conversation has really dropped back to pre-event levels. So Twitter moves on pretty rapidly from whatever kind of content we were talking, or whatever kind of event we're talking about. Now, while this amnesic version of Twitter is in some sense troubling, it's nice from a detection standpoint because we can compare the kinds of keywords that experience these bursts with what we'd expect if there was no event at all. So this is the volume of particular related keywords given no event. We refer to this as the background model. We can compare it to tokens that appear in the foreground model, or things that experience this spike in usage. And then we can quantify this distance between what we would have expected to see given no event and what we actually saw given some crises. And then we can score this using whatever scoring method we use, or you might want to use. For us, or for me, I used Kolbeck-Leibler divergence. It's basically how much distances there between what we expected and what we observed. So then we can rank any token in Twitter by this scoring mechanism, and then we can look for frequently divergent keywords, both within a particular kind of disaster. So what kind of keywords frequently diverged during earthquakes, during hurricanes or climate-related events, or during terrorist attacks? And then what is the union of all of these, or the intersection across all these different kinds of events? What are the frequently divergent keywords that are used across all disasters? So we have an algorithm for this, basically given some set of similar events, a time frame for when those events occurred, or a date when those events occurred, and some seed keywords that describe what that event is. We can build out a small vocabulary that says, here are the keywords that experience some burst or were highly divergent across the majority of these events. So given this algorithm, we need some social media data to apply this to. What data did we use? We have an archive of Twitter's public sample stream running from April 2012 to August of 2016. This is about 6.5, 6.6 billion tweets. Or on average about 4 million tweets per day. So this gives us a pretty substantial data set that we can look at for a number of different events for about a 4-year period. But that tells us what happened on social media. That gives us the social media insight. We also need to know what happened in the real world. We can't just look at social media. We have to know what other events happened. So we have, oh yeah.
Do you mind questions halfway? Or?
No, go ahead.
So I did a little bit of Twitter analysis of not a little bit, but a lot of Twitter analysis, and the number one problem that we're always facing is when you use the public stream API, you're getting a 1% or less sample of tweets.
Yes.
Okay. And I think you looked earlier, you were running a non-parametric test to compare the distributions. So your explanatory power there, your statistical power is probably going to be very, very weak. But having said that,
most impactful kinds of events, this works relatively well. I'll actually talk about some of the issues and biases in the data to address this exact problem. This is a known limitation of this data set. It's a good question.
How about another kind of background question? Do you envision kind of doing these analyses primarily ultimately for policy uses, or is there a scientific question you're trying to resolve?
So there's a scientific question. The paper that this was about was, when we look at the consistencies between the response, what does this really tell us about people's information needs or desires? Like, if thoughts and prayers are so common, why might that be? There's some existing literature that shows in the offline world, at least in the United States, religion is the primary kind of thing here. And then I'll get to this later on, but if we can look and see what the prevalence of these kinds of consistent responses are on Twitter, what does that tell us about the actual event on the ground? And does that give us a different way to quantify the impact?
Typically, we would expect a certain thing to happen, but for this particular crisis, we have a substantial deviation, and that matters for some other reason. Is there a delta kind of?
So I haven't looked at that, but there are definitely cases where that happens, and I talk about like pure potential reasons for why this is actually going on. Other things. Questions are good because it allows me to pause and take a drink. Okay, so Twitter data, we have a bunch of Twitter data to look at. Definitely there are issues, limitations with this. But we also need to know what's going on the ground. So we need some ground truth data sets. So for terrorism, we can look at the University of Maryland START Center. They have the Global Terrorism Database that purportedly has every terrorist attack over the past 40 years, whether it was successful, what kind of terrorist attack it was, and the casualty rate associated with that event. For earthquakes, we can look at the Significant Earthquake Database provided by NOAA that tells us, actually this one is like every significant earthquake for the past 4,000 years and the associated loss of life and estimate of damage in dollars. So these are two really good high-quality databases for ground truth data that's separate from social media. For climate-related events, which we're also interested in, there's less of a single unified data set for this, so we use CrisisLex, which is a curated set of climate-related events and some associated descriptions for these events. So, given the social media data and these ground truth sources, we look at 21 different disasters of 3 different types, looking at 7 in Africa, We look at 7 different earthquakes, from the Nepalese earthquake in 2015, an earthquake in Italy in 2016, several others, one in Ecuador, and then 7 different climate-related events, from Hurricane Sandy, Typhoon Yolanda, Australian wildfires, the Alberta floods, these kinds of things. Now, applying in the aftermath of terrorist attacks, the most commonly used keywords are affected, tragedy, these kinds of things. In the aftermath of earthquakes, people consistently refer to the earthquake in several different languages, so earthquake, seismo, gimpa, terremoto, and the magnitude of the earthquake, how strong it was. And in the aftermath of climate-related events, the most common references are about safety, staying safe, where to go for help, what kind of damage, and what kind of evacuations there are, or what kind of information do we see about evacuations. And across all 3 of these disaster types, the words affected, victims, praying, and prayer are also highly common. So first off, the thoughts and prayers effect really is something that we can see from the data. Doesn't really matter what kind of tragedy has happened, this is how people respond, regardless of whether they're approximately, in case we use casualty rates. So we can look at the daily volume on Twitter for these different vocabularies and compare this to the casualty rates from the GTD, and compare this from the casualty rates from the significant earthquake database as well. And this tells us a couple of things. So this blue line is the number of casualties globally by terrorist attacks per day, and this yellow line is the number, or is the normalized frequency of, we have a big spike in the Twitter usage or Twitter, this is the Boston Marathon bombing, and in November of 2015, so this is the Paris November attacks. But in general, there's not very much relationship between these two curves. In fact, the correlation is really low. In general, Twitter's response to terrorism does not match the casualty rates brought on by successful bombings, successful terrorist-related bombings across the globe. Yeah?
Just a comment on the number of terrorist attacks. So those have been shown to follow a power law distribution.
Okay.
So you're going to end up with, depending on the slope of the power law, you're going to end up with either an undefined mean or an undefined mean and variance.
Mm-hmm.
And it won't, I'm curious about whether you've looked at the actual tweets that follow some kind of distribution that will also have problems in terms of definition of the modes.
Yes, we know that the kinds of responses that events get on Twitter also is power law distributed, so you expect that there's going to be some small set of events that get huge volume or huge traffic, and most events get very little, and then there are similar issues. But I haven't tried to quantify that in some sort of comparison here.
So a similar question, Cody, would be that if these are finance data, so you basically have the event happens and then there's some discussion of it. In the finance world, you would do something like you would say, there's some news event, and then there's the market response, right?
Yeah.
And so you would not, in finance, you would not want to look at correlation as in Pearson, but you want to look at some kind of lag structure, right? So basically some autocorrelation.
Right.
And so if you, for example, so if you were to put in some, some lags here, but I guess the claim from the earlier chart was that basically all the response dies out in a week anyway, right? But do you have a sense if you tried some lags, you tried some autocorrelation, would you get any? Would there be any in here or not? Would there be more than that?
So I imagine if you were to do some sort of smoothing, so if you were to do some sort of autocorrelation or moving average or something like that, or even some sort of lag. I actually did try the lag. Okay. It's like one would expect that maybe for global issues, so things that don't happen according to the western or eastern seaboard, and there wasn't any. Overall, the main issue is that if you look at the days that have the most significant impact on the GTD versus Twitter, you see essentially no overlap. Twitter responds very highly to the Paris November attacks and very highly to the Boston Marathon bombing.
And this is in all languages or just English?
Just English, which has its own biases that I'll talk about.
Yeah, okay.
Yeah. Whereas if you compare this to the GTD, all of the most significant terrorist attacks in the GTD happen in other countries, especially non-English speaking countries, Sudan, Syria, Afghanistan, and Libya. But there's no overlap here. Now, I'll talk a minute about what happens if we break this down by region. But first, let's look at what happens if we look at earthquakes. So earthquakes, we see a different story. Earthquakes, so this is the Nepal earthquake in 2015, and we see the overlap between the significant event database, or significant earthquake database, and Twitter. So Twitter is the red line here, the SED is the blue line. That actually overlaps really highly, but we see no overlap here. So this is the earthquake in Italy, where lots of people responded on Twitter, but there were relatively few casualties. But we see moderate correlation here. And again, this is the stronger correlation.
Twitter handle, because
Yep.
most of the Twitter handles, I'm from Nepal, so obviously people using Twitter are in Kathmandu, which was
Yes.
also here, but the epicenter was outside of Kathmandu.
Yes.
And probably
So this is another known limitation of the data that I'll talk about. So if we do the same thing and we look at the most significant days, we see some better overlap here. That in Twitter, we have the highest impact day was corresponded to the earthquake in Italy, and then these 3 days were around the earthquake in Nepal, and this was an earthquake in Ecuador. If we compare this to the significant earthquake database, we see some overlap, where Nepal is the most significant, followed by an earthquake in China, the earthquake in Ecuador, an earthquake in Iran, and another earthquake in China. But we do see overlap here, that Nepal is represented in both, and this earthquake in Ecuador is also represented in both. But that's at the global level. So looking at all events across the world and English Twitter, we see issues. But with the GTD and with the significant earthquake database, we can break this down by region. And what we see is, here we have a color problem. What we see is if we only look at North America and Western Europe, we see a much stronger correlation between Twitter's response to terrorism and the number of casualties incurred. We see a very similar kind of effect if we look at earthquakes. Same thing, North America and Southern and Western Europe. In addition, we see Nepal, or excuse me, Southeast Asia, which is driven primarily by the Nepalese earthquake in 2015. So what this says is, correlation is strongest in North America and Western Europe, subject to constraints of language. So we're talking about English and sampling issues with the public sample stream, these kinds of things. But at least it tells us that basically the kinds of things that we already knew. Social media is pretty biased towards the Western context, or at least English social media is biased towards the Western context. So some insights about what this data is telling us and what the limitations are. First, going back to the language that people are using, the way we explain this, or the way we've brought in the existing literature on this, is that after a terrorist attack, all these references to the attack and to police and victims is really about interaction with law enforcement. So there's a lot of prevalence to interaction with law enforcement here. And the survey work shows that in the aftermath of terrorist attacks, at least in the United States, people are more likely to reach out to law enforcement, and this effect is decays with distance from the event. So after the Boston Marathon bombing, people in the Northeast were much more likely to interact and engage with law enforcement, whereas people in California had basically no effect. In the aftermath of earthquakes, people really want information about the news, where was the damage, where did the earthquake happen, how intense was it. In the aftermath of climate events, people really want to know where they can go to seek shelter. And then across all of these events, these references to the victims, prayer and praying, regardless of whether you were actually physically proximate to the event or directly affected by the event, is a different kind of information need around social support. So these are all really different information needs. These three are sort of disaster type specific, and this is some information need that is across all the disasters. That when some tragic thing happens, people want to feel engaged and have some sort of positive response or have some sort of positive interaction about what is otherwise a tragic event. Now, we've identified this regional bias in social media around these events. There are many possible reasons for this. One is, of course, language. The study was only using English language keywords, so terrorism, the names of the places, while English is the most common language in Twitter, it still only accounts for about 20% of the network, so there are issues here where not everybody's going to tweet in English. I did try and use Google Translate to address this issue by English, Arabic, and Japanese, and that didn't give us any better results. But in conversations with other authors or other researchers who have looked at events in like the Middle East, at least the social support aspect seems to be conserved. In the aftermath of a Turkish mining disaster, or a mining disaster in Turkey, there were still significant references to religion and thoughts and prayers in Turkish. But it's unlikely, I don't think Google Translate is sophisticated enough to capture the differences in language. That would capture the effect here. Definitely demographics is a big issue. So say you're in Chile, where we know Chile is prone to earthquakes. If you're in northern Chile and an earthquake happens, there just aren't that many social media users in northern Chile. Most of the Chilean social media users are in Santiago, which is further south in the country. So there's a demographic issue there in terms of population. Definitely there's one in terms of access. So if you're in some rural area, either in India or maybe you're in rural America, there might not be an infrastructure there to support using Twitter, and especially if it's been damaged after a disaster. This brings up a whole issue because there's a lot of work on crisis informatics, but crisis informatics based on this is potentially most useful or has the most effect, most power in places like New York, DC, LA, Tokyo, places that are highly developed and have high population density, but they already have infrastructure for disaster and emergency response. Whereas in more rural places that could benefit most from this kind of thing doesn't work very well because of all the issues with infrastructure, socioeconomic status, and access, these kinds of things. So this brings up a problematic thing for crisis informatics as a field. And then there are all kinds of geopolitical issues. So in this earthquake data set that I showed you, two of the most significant earthquakes were in China. I'm only looking at Twitter, and Twitter is not allowed in China. So of course you wouldn't expect to have a significant response from the Chinese on this particular platform. So trying to do this kind of sampling in Twitter is really hard. We can at least say that there is some stronger effect in North America and Western Europe, so we can learn something about these particular cases subject to these constraints. And this is one of the things that I think is really interesting about this, where we can look at this kind of impact, or this kind of response in social media, as another kind of way to evaluate impact. A lot of times people evaluate impact based on casualty or dollars. This is shown in the GTD and the significant earthquake database because that's how they measure impact. And those are valid axes of impact, but it's certainly not the only one. Social media may provide us a different way to evaluate the societal impact of these kinds of events. And this fits with the existing criticism that Twitter often gets, is that when a terrorist attack happens in Ankara or Istanbul, Twitter doesn't really light up. When a terrorist attack happens in London, or even a foiled one happens in London or New York or something, Twitter explodes about this kind of conversation. Now, maybe this is because of these sort of differences in expectation, that where places where terrorist attacks are more rare, then there's a higher societal impact, even if there are fewer casualties. So being able to evaluate or have another measure for societal impact is really important, especially for something like terrorism, where affecting social impact is one of the major points, major goals of terrorism. Of course, there are all kinds of limitations to this. As I mentioned, that we've talked about, the public sample stream is incomplete. The sampling rate's really low, and we know there's some other work that if you focus on a particular area, so if you look at like rural Washington, there's some work that says if focusing on rural Washington, you can still get some significant insight into what goes on in that particular town using social media, but you have to know where to look beforehand. So there are issues here. The terrorist events we looked at were Western focused. We did include two from Africa, the Kano bombing in Nigeria and the Westgate Mall attack. But that's two of seven, so the other five are primarily Western focused. And then everything that we did in terms of keyword selection is biased to English. So we know there are limitations here. we can still get the we can still see some interesting results about constrained areas in the United States and Western Europe. Now, the last thing I'll talk about is, we've talked about the disaster scripts, what these look like, what we can learn about the disasters, and now I want to talk about how we identify content during these events that fulfills these information needs. So just to refresh, these are different information needs that your general social media user may have or may exhibit when they go to social media during a crisis. They want to find some information about where they can go to stay safe, or share information about evacuations. They want to engage with law enforcement, and they want to engage in some sort of positive. What kind of information? Looking at or requesting information from emergency responders. There are calls to action. People need to be told where to move during evacuations. They're sharing that kind of information. All kinds of reports, these kinds of things. So right now we have very little insight into how prevalent these different kinds of information needs are in social media, or how we can identify them in the larger scale. So working with NIST up the road for the text retrieval, the University of Glasgow put together the incident streams track at track. This idea was, using social media, can we provide additional support to emergency services to let them get access to what kind of information is being shared on social media during disasters. The main tasks that we look at are, given some stream of tweets during some disaster-related event, can we do some classification task to say, well, this tweet is probably about sentiment. This tweet, a water main is broken in Edmond, it's causing flooding. This is an observation about damage. This tweet, power is out at a nursing home on 4th Avenue. They need help. That's a request for aid, a request for assistance. So can we classify these kinds of information needs? And then can we provide some sort of priority score to address what law enforcement and emergency responders really need to see the most? So between these three tweets, this one is likely the most important. This one has potential loss of life because there's a nursing home without power. A law enforcement agency or emergency responder may need to see that very rapidly. Versus this one, which is still important because it's about infrastructure or damage, and then an emergency responder may not need to see the sentiment one at all. So in terms of information overload and making sure that the correct piece of information goes to the correct person or the correct responsible party for that particular task. So working with 11 different, we put out for Trek 2018 a call. We got responses from 11 different groups across the globe. They submitted 39 different systems to help do this sort of classification. So looking at these events, augmented with Crisis NLP and some data from CrisisLex, all these different organizations built their own machine learning platform to try and identify what these information needs were. So I built 4 different systems here, ranging from pretty straightforward, unsophisticated, to more sophisticated. First one is just your standard bag of words model, weighted on term frequency. We do some label spreading to identify or to deal with sparsity issues in the training data. We use fast text for a more sophisticated Engram embeddings method, and then we do the same sort of labels, semi-supervised learning thing there. I'll give you some insight or some high-level talk about our high-level motivation for what we're doing here. Given some tweet, we break it up into a bunch of different keywords, potentially bigrams, and then we build some sort of term vector to identify what this content looks like. For Engrams, we compress this dimensionality to some much lower dimensional space, train this on a large number of English tweets, and the real motivation for this is this. So in the aftermath of crises, we know that huge amounts of content is about this sort of emotional support, sentiment kinds of content, and this pattern is very prevalent. Pray for insert some location. And we want to be able to capture that. It doesn't really matter if you're saying pray for Paris, pray for Orlando, pray for Boston. It's still, you're capturing the same kind of sentiment. So with an Engram embedding, we can do this. We can capture this kind of information. Now the last issue is an issue of data sparsity. For the 2018 track, we only had about 1,000 labeled data sets. How do we handle that when there's huge amounts of data on social media? We know that the sentiment case is probably the most common. but the search and rescue case, which is somewhere here, somewhere. The search and rescue case or the move people case are the highest priority, yet probably have the fewest amount of data. How do we handle this? So I did this by pulling in the disaster scripts that we have that I showed you before, pulling out a bunch of tweets that contain these, and then basically building some model that says, well, what are other kind of similar content from a larger set of Twitter data? Now, unfortunately, the label spreading thing didn't work, but the Engram embeddings actually did really well in terms of capturing the sentiment and the different kinds of information needs that people were sharing. The naive Bayes really low-level model, or really simplistic model, actually performed middle of the pack, and then the more sophisticated sort of semi-supervised models didn't really perform well at all. And that's some technical content for what we did. Certainly you can go check this out if you want. But the really interesting stuff about this is what we found when we asked people to rate or classify this information. Now NIST is nice in that it provides us annotators to actually hand label this content. So we hand labeled a bunch of tweets that were captured by these systems, and what we found when we asked our annotators to label content for priority, that about a little bit more than 10% of content that was published to social media during 21 different disasters is high priority or critical content that emergency responder needs to see this pretty rapidly to act on it. So there actually is a significant portion or a significant volume of this kind of information on social media. And we can break this down by event or by information type, and we see things like official responses, goods and services, moving people, search and rescue. These are the highest priority content or pieces of content that are on social media and get a lot of traction. Certainly, a lot of low quality or low priority content is being shared, but this is a non-negligible amount of content that we can't just ignore. Now that's an interesting response or an interesting finding in and of itself, but if we look at these 39 different systems that people submitted, how well do these systems actually perform at identifying this high priority content? And what we find is, well, search and rescue and official news actually performs decently well. It's in the top 6 of, if you take the best performing system for each information type or each category, we get okay. I mean, it's not great, but it's at least in the top 6 for information wanted, and then the majority of other high priority information types. We actually, across the board, all the systems that participated don't really do well here. So this is problematic. This means the most important information that people are sharing on social media, we don't really have a good way to identify it in an automated way, which is bad. Social media has so much data in it. We need to provide decision support systems for this. How do we do that? So if you're interested, TrekIS is running again in 2019. And if you want to submit a system or you want to be involved, there's a nice Get Involved button on the website, which actually is just trekis.org. There are a couple ways to get involved. In May of this year, we're doing a data challenge using the data from round 1 with a workshop at SIG-IR, the Information Retrieval Conference, and then the main track at Trek is probably going to be due in August of 2019 for the Trek proceedings in November. So by all means, get involved in this if you like, or if this kind of thing is interesting. So that's it. I hope we've talked about this, that at the end of this you can remember public social media response shows consistencies across disaster and these different information needs that are expressed. And while we can automatically identify content that fulfills some of these needs, the most critical content is still difficult to identify. So all right. Thank you very much. And I'll open it up for questions. Comments, nasty accusations about how all this is completely garbage because it's social media. That's fine.
I can start off with that.
Okay.
No, I mean, I promised myself that one of these days I'm going to watch a presentation where a scholar is telling us something about social media, and he or she begins with the limitations, because that will be most of the talk. So I mean, so much of this is hard to pin down. statistically, because unless you have the population scale data, which you won't get from Twitter, so much of this is unreliable and long-term. You build a model on a data set, you try it on a different data set, and it completely fails. But having said that, that doesn't mean that it's not descriptively strong. So there's a lot of descriptions here that are very, very useful and can implicate policy.
Yeah, so there are two answers here. One, so certainly for the first 2/3 of the talk, yeah, absolutely. I mean, really the most valuable thing there is finding a way to identify keywords that are consistently used, because that's valuable for an information retrieval task. Obviously, it's not going to work in all cases. Yeah, there's definitely issues with the sampling strategy, all these kinds of things. From a detection standpoint, for the last bit of the task, the TrekIS stuff that I showed you, I think that's still valuable and is less impacted by the sampling issue thing here, because it actually kind of abstracts away a lot of that. So if we have a particular area of interest, like if I'm an emergency responder for some particular domain, say Southeast Alabama or the Southeast United States rather, and I have the money to like go to Twitter and say I want all content that's published from this particular area, and then we can apply these models to it. The whole point for TrekIS is to build a data set and set of metrics that allow us to evaluate how well these systems work across events. Because so the TrekIS stuff is being published at Engrams, which is a conference for crisis informatics, and there was a paper released at or published at Engrams last year or 2 years ago maybe that was basically crisis informatics has been a field for about 10 years, and we've essentially accomplished nothing. In terms of like being useful to industry or like actual practitioners, we haven't done anything. We've not transferred this technology. And part of the issue is exactly the things that you're saying, that practitioners don't want to rely on a technology that they fundamentally don't trust. So if we provide a standardized data set that lets us say, well, we know where we're failing, these high priority information types we're just missing completely, that it gives the field a place to say, here's the issues of the field, we need to focus on these. And then we can go back to the practitioners and say, well, here's the standardized data set we've built over the past several years. It works across all these different events in all these different places. Subject to these constraints, it works this well. And you can have some faith in it.
One of the things you may want to add, and it does sound like an add-on at this point, but it's a useful one. If you're used to certain patterns of traffic, and you're suddenly not getting anything from south of Canal Street in New York City,
right?
That's important information.
Right.
Telling people when something you expected has gone missing may be the best, both the most reliable and the fastest information you can give them that something's going on.
And that particular method may work well for two things. One, it may address this issue of not like these kinds of things don't work well in rural places or places with less infrastructure. Yeah. Well, if we say, well, we don't care about the content, we just care about are we seeing a signal at all, when normally we see something and that's gone, that's highly indicative. And then also for terms of censorship, where countries will be like, protests are happening, we're just going to cut off social media access. This would be useful for that as well.
Yeah.
Yeah, absolutely. Thank you.
So Puerto Rico after the hurricane, one of the big indications that there was a lot of damage in the rural area was that people just stopped being able to get through to anybody.
Yes, absolutely.
So you thought of you were prioritizing the tweets, but you still had, about 15% of high and critical tweets that were coming out of this. And that's still going to be a ton of data for a lot of different personas. Did you guys look at then the different personas and prioritize amongst that? So a fireman sees certain types of tweets versus a first aid person or something else, or is that the next paper?
So we did not look very deeply into that. We did do this. So you can't really see it in this figure, but it is in the Engrams paper that's being published at the proceedings at Engrams in May. So like search and rescue has a pretty small variance in the annotations for how critical it was. Basically, anything that was search and rescue was going to be high priority. Whereas the second one, move people, that had much higher variance. And this might be driven by the different kinds of content that people are sharing. We didn't go much further than that about talking to, like, well, as a fireman, what is the most critical information for you in this particular slice versus a policeman or somebody at FEMA who's interested in like larger scale things. We have not done that. That's a good question. Yeah.
So for first responders, wouldn't they be getting this information beforehand, like through calls and everything? Like, how is this aiding what they're doing?
So that's an excellent question. This is more designed. So this kind of stuff is more designed for somebody, or not for somebody, but for a group of people who sit in a large emergency response center and need to have an understanding of where to send first responders. Sure, but also a larger set of understandings about like what is the damage in a particular area. Because a lot of this content doesn't necessarily have like I need to send first responders there now. Certainly, search and rescue does. But reports about damage, so like in the wildfire case, where like wildfires in California are spread across a huge area, a lot of that is why I'm really interested in like the first and third party observations that people are posting. The pictures that people post about damage is also highly useful, but you can't get that from a 911 call, and a 911 call may not prioritize just somebody saying, "Hey, I saw the fire spreading here." But that's an excellent question. Certainly, there is room for both of these things. A really important issue is how we handle this kind of thing, because sometimes people can't call 911. So I was in Alabama in 2011 when the supercell tornadoes hit North Alabama, and it basically took out our infrastructure for 7 to 10 days. We didn't, like all the cell phone towers after 2 days, all their backup power went out. So we had just enough service to send text messages and communicate via tweets, because you could text to Twitter, but not enough to actually make phone calls. The infrastructure just couldn't support it. But 911 can't handle, in the United States at least, 911 can't handle text messages and certainly aren't looking at tweets. Yeah.
In 911 usually, if it's a cell phone call, take note of where it came from.
Mm-hmm.
That's a huge advantage.
Yes.
I'm old enough to remember having worked as a dispatcher in a fire station one summer, back before we had cell phones.
Mm-hmm.
And one of the things that got pounded into me early and often and hard was the first word out of your mouth is, where?
Right.
If you say something like, okay, they think you know, and they hang up, and you still don't know where the fire was.
Right. No, that's an excellent point. And then going back to this question about damage, so I didn't show it in here, but after the Boston Marathon bombing, people were showing or sharing images of where things had happened within 2 minutes of the event on social media. So again, 911's not going to see that, and 911 probably doesn't care about like here are images. How can we respond now? But certainly law enforcement cares about it, like over the next day or something along those lines, to figure out, well, where did it start? Where did people move? These kinds of questions. Yeah.
So I think you said you looked at 21 different events. Why did you choose the events that you did?
For terrorist attacks, we chose ones that got significant coverage because we needed to have some kind of idea that there would be social media data for it. Also integrating some events that got less coverage for trying to minimize bias reasons. Same thing with earthquakes. We needed to know that like some of the most significant earthquakes, like in Iran or in Ecuador, or there's a big one in Afghanistan. We couldn't look at that because we know that there's not enough social media content there, or there aren't enough social media users there to respond, and the number of people who were impacted, while large, don't have access to this kind of thing. And then for climate events, we used the Crisis Lex group. It's a great question, though.
So given that Twitter lights up quite differently depending on population, etc., would it be how hard would it be to normalize, for example, something like there are two events that are can be complementary, two earthquakes in Chile, one in Santiago, one somewhere else, but in the less populated area, wouldn't it be possible to normalize and try to figure out, is there kind of a universal response function or something?
Yes, yeah, that should be possible. So I've done some some look or some analysis on social media data and how like the amount of geolocated data that's present in the network correlates with census data, and it works pretty well at the state level. Geolocation data is pretty sparse in Twitter though, so it would be an additional effort to do like geolocation for a large group of like a large area, and then integrate that in. But in principle, you absolutely could do it, and it probably would be pretty helpful in getting some understanding about average response given given population size.
Anybody else? Well, let's thank Cody again. Will you be around for just a little bit, Cody, while there are other questions? Maybe?
Yeah, absolutely.
Okay.
Do you get into video transmissions at all?
No. So I'm actually on the job market right now, and one of the things that I want to push on is integrating multimedia.